So this question involves the second derivative and how we can use the second derivative to classify the turning points and also find points of inflection. So the question is asking us to find and classify any turning points. So turning points happen when dy dx is 0. So dy dx, as we can see, is a function times a function. So the product of two functions, we need to use the product rule. So if y equals u times v, then dy dx is given by the product rule here. So I'm taking my u to be e to the 3x, and then du dx is 3e to the 3x. My v is x squared plus 8x minus 5, so dv dx is that. And then popping these things into here gives me that expression for dy dx. I'm going to tidy that up a little bit because I need to know when dy dx equals 0. So there's my tidied up expression for dy dx. Solving the equation dy dx equals 0 gives me two values of x, which I'm writing to 4th place decimals for the moment. Okay, now those are my x values of the turning points. I need to know the y values, and I need to classify the turning points too. So popping these values of x into the expression for y, I get to 2 decimal places these two values of y here and here. So those are my two turning points. But how do I classify them? Well, I'm going to use the second differential, the second derivative. So if I've got this expression here for dy dx, then I'm going to be differentiating that. So once again, I've got the product rule. I'm going to take u equal to e to the 3x and v equal to that. And then when I put that into the product rule, I get an expression for d2y dx squared. So that's v du dx plus u dv dx. Okay, that simplifies to this expression here. So I need to work out whether this is positive or negative when x is 0.26 and minus 8.93. So at A, this turning point when x is 0.26, when I put x equals 0.26 into this, I get a figure which is greater than 0. So this turning point is a minimum. And when I put x equals minus 8.93 into that expression, I get d2y dx squared is less than 0. So B is a maximum turning point. So I found and classified the turning points. I've now got to find the coordinates of any non-stationary points of inflection on the curve. So a point of inflection happens when d2y dx squared equals 0. Well, we've got an expression for d2y dx squared equals 0 here. So e to the 3x can't equal to 0, so it must be when that equals 0. So 9x squared plus 84x plus 5 equals 0 gives us two values of x. So those are the x coordinates of the non-stationary non-stationary points of inflection. And when we pop those into our expression for y, we get the y coordinates as well. And I'm expressing them, all the answers, to 2 decimal places as required by the question. Whew.